All right, so this is the review for the Chapter 11 Quiz 1. I highly recommend that you stop this video, try all of the problems on your own, and then use the video to check your answers and to understand the problems you're struggling with. Because the best way to prepare for a quiz is to try everything on your own and then make sure you clarify anything you don't understand. And the easiest way to do that would be watching this video after you've attempted all these problems. All right, so number 1, let f of x equal 3x, or 3 over 5 to the x power, and then find f of negative 3. So remember, we're going to have to be careful with these types of problems because we have to remember, am I going to put this negative 3 in place of my x, or am I going to put negative 3 in place of f of x? And the easiest way to look at that is, what would have been in this spot? Well, wasn't it originally f of x? So this negative 3 is in the x position, so that means we're going to put negative 3 everywhere we see an f, or an x. So f of, instead of x, we're putting negative 3 equals 3/5 to the negative 3rd power. So then we can go ahead and distribute this exponent into each of these pieces. So we'd have 3 to the negative 3rd over 5 to the negative 3rd. Remember that we don't like negative exponents, so we're going to have to move these around to make them positive. So 5 to the 3rd on the top and 3 to the 3rd on the bottom. And 5 to the 3rd power is 125, and 3 to the 3rd power is 27. So our final answer is 125 over 27. Now, number 2 is very similar, but in this case, if you're looking at this, it's telling you that g of x is the same as this. So in this case, this 1/12 is replacing g of x. It's not replacing the x because it's not in the spot of the x. It's replacing g of x. So I'm going to take the 1/12 and put it in place of the g of x. So we would have 1/12 equals 144 to the x power. So in this case, what we'd probably want to do is try and get a common base. And the nice thing here is if I look at the smallest of the two is 12, I can actually make both of them be a base 12 because 12 to the 2nd power is 44, or 144, and then we would raise that to the x power. 12 to the 1st power is 12, but to get it in the denominator, we have to make it negative. Now when I look at this problem, we have an exponent to an exponent, which really means we multiply them, and 2 times x is 2x. So we have 12 to the negative 1 equals 12 to the 2x. Well, now that my bases are the same, then that means my exponents would have to be the same for this to be equivalent. So we would say negative 1 equals 2x, and then to solve for x, we divide by negative 1, so x has to equal, or sorry, not dividing by negative 1, divide by 2. So x equals negative 1/2. And remember, you can always check that in your calculator, right? If we want 1/12 to be equal to 144 to the x power, we can go ahead and take out our calculator, clear everything out, and do 144 to the, we're trying to do negative 1/2. So you could either put it in as a fraction or just in parentheses, negative 1 divided by 2. And because this is also 1/12, we can just do 1 divided by 12 here, and we can notice that those are equivalent, which means we are on the right track, and that's the right answer. Okay? For number 3, we're doing basically the same idea as number 2, but we're just skipping a step. We don't have to do the substitution step here. They've already set it up for us. So when I look at my bases, I have a base of 2, I have a base of 32. Well, I can change 32 into 2 so that I have the same bases, because 2 to the 5th power is 32. And then we'd raise that to the x plus 1. So then we'd have on the other side still 2 to the 3x plus 1. Now remember, exponent to an exponent means we're multiplying them. So this is really 2 to the 5th x plus 1 equals 2 to the 3x plus 1. And now that our bases are the same, that tells me that my exponents would also have to be the same for it to be equivalent. So we know 3x plus 1 has to equal 5 times the quantity x plus 1. So we can distribute in to get 5x plus 5 equals 3x plus 1, and then start solving. So I'm subtracting 3x, so I'd get 1 equals 2x plus 5. Subtract 5, so we'd have negative 4 equals 2x, and divide by 2. So x equals negative 2. And again, since this has so many steps to it, I would definitely take out my graphing calculator to check to see if this is accurate. So on the first side, we have this 2 to the 3x plus 1. So 2 to the 3 times negative 2 plus 1. And we've got our answer there. And for the other one, we have 32 to the x, which is negative 2, plus 1. And since my decimals are the same, I know that those are equivalent. So yes, x has to equal negative 2. Checking your answers on your quiz tomorrow will make sure that you know that you've got the right answer. And if they don't turn out equivalent, you should retry the problem again to see if you can get the correct answer. All right, number 4. If $250 is deposited in an account paying 7%, compound it continuously. Okay, so as soon as I see how it's compounded, that tells me I have to choose between those two different formulas. Since it's continuously, the formula that I have to use is A equals P, E to the RT, because we use E whenever we're talking about compounding continuously. Then, what will the amount be after 4 years? So I have to decide what's my A, what's my P. Remember, the E is a number, just like pi, so I don't have to worry about that. What's my R and what's my T? Well, we're depositing $250, so that's the principal, that's the starting amount. 7% is the rate, but remember we need to make that a decimal, so that would be 0.07 for my R. And then 4 years is the time, so 4 is my T. So A equals 250 e to the 0.07 times 4. And again, now I can just get out my calculator and go ahead and type that in. So 250 to the, oh, I forgot my e. So 250 e to the 0.07 times 4. And that gives me 330.7824, remembering that we're talking about money, so we'll just round to the second number. 2 makes the 8 stay the same. So then I have to write my sentence. So since this is what it would be after 4 years, we need to specify that. So after 4 years, the account will have $330.78. Because remember, if it were a different amount of time, that quantity would be different as well. All right, so let's go ahead and take a minute and look at the next page. So number 5, write 3 to the 4th as a logarithmic equation. So we have to change this into a log, right? So remember, when we talk about the log, right, it's log of the base, log base b, of the answer equals x, which is how I kind of like to think about it. B means it's the base, and in this case my base was 3. X is like my exponent, so this is my x, and my answer was 81, so that's my A. So log base 4 of 81 equals, sorry, not base 4. I even said my base was 3. So log of the base, which was 3, of my answer 81 equals my exponent, which is 4. So log base 3 of 81 equals 4 is now in logarithmic form. All right, so let's take a minute and look at our graphs. Right, so when we're talking about the graphs, you're going to always have to be able to state domain, range, and find your asymptotes. All right, so the asymptote, remember when we're talking about exponential, we really only have the horizontal asymptote, which comes from the end. Right, so this gives me my horizontal asymptote, whatever's added or subtracted at the end, so it's y equals negative 2. Then my domain is always negative infinity to infinity, because it's going to keep going in both directions. My range will be easier to tell once I graph it, so I'm going to wait until I graph it. So let's do that now, remembering that we go into the y equals button, right? And we can clear this out. And so it's -3 times 1/3 to the x. And yes, you could type this in as a fraction, but remember, if you type it in as a fraction, then all your table is going to be a fraction, and to me that's harder to graph than the decimals. So -3 times 1/3 to the x minus 2, so we can graph it to get an idea of what it looks like. So if I look at this, remember, range is my y's. So my y's are negative, and they go up until -2, right? So -infinity is the smallest, -2 is the highest. So now I can say my range is -infinity to -2, but it does not include -2. And then I'm going to go ahead and also at this time go ahead and put in that horizontal asymptote that was confirmed by the look of the graph on the graphing calculator. All right, so now we can go ahead and create our table and use that to graph. Remember that you need to show me your table on the quiz or the test to get full credit. And so we want to be approaching -2. So right here I can see that I'm getting into that -2 section. So I won't use -1, -11 because it won't show up on the graph. So the first one that I'll write down is 0, -5, 1, -3, 2, -2.3, 3, -2.1, 4, -2.0. Well, it's 2.03, right? Because it's never going to be exactly. And if I round that appropriately, it'd be 2.04. All right, so it's going to get close to 2, but never touch it. So now I can go ahead and plot those points. So 0, -5. I know that -1 was at -11, so I could technically plot it and just put it over here so that I get a better idea of the shape. So then 1, -3, 2, -2.3, 2.1. It's just getting closer and closer. So the idea is here is what my graph looks like, getting close to but never touching or crossing that horizontal asymptote. All right, so you can go on to the next video to see the last of this.